All right. This is Stacy, and this is Understanding the Plans, the Foundation. Yep. Thank you very much. So, today, what we're going to go over in this set is we're going to review a foundation for a hotel. Is that what we're doing? For an extended stay. And this is for the rebar contractor, for the concrete contractor. There are a lot of intricacies about the foundation, a lot of detailed section views, and we'll go over each of those, how to read those, how to determine your rebar total. So if that's something you like, please make sure to subscribe so you can be notified and hit the bell of this information, and others can as well. So,
Are you ready?
okay, so before we start, it's always a thought experiment I want to start you with. No pictures, no plans, no anything. And I want you to think about, what is the foundation? Where can I find it? What's it all about? And so let's talk about that first. All right. The foundation is the bottom of the building, right? So if you have a foundation, then you probably have a project from the ground up. Foundation consists of the continuous footer, which is usually holds the exterior walls, and all of the exterior load bearing walls are connected to that continuous footer. And sometimes portions of that foundation bottom or that footer will come into the building. So if you have any walls that are connected to any part of the foundation continuous footers, okay, and we'll go over that, or in a wall or column embedded into a column pad, then that's a structural member, that's a structural component, it's a load bearing component. And so if you remove that component without providing some kind of bracing, like if you are going to demo or something like that, the building will fall. Okay, so the foundation consists of really the perimeter, which is the continuous footer. Sometimes that footer will come into the building at some portions, and if it does and walls are built on that footer, then that's a load bearing wall. Okay, so we brace basically for our foundation. We make the formwork, we form it out. Then we place the rebar based on what the structural engineer decided that the configuration of the rebar and the column pads and all of the structural steel and all of that had to be. And then once all of that is set, we drop the concrete in cubic yards. And so what we're going to go over is this foundation, how it's built, how we think about it, how we look at each of the sections. And if you have any questions, you can always put your question in the section portion, or in the comment section, or you can email me at education@sfjohnsonconsulting.com. Thank you. Thank you very much. Thank you very much. So what are we looking at? This is a very rectangular shaped foundation for this hotel. And this is actually I believe it's an extension to an existing, but this is the foundation of the existing, of the new construction. And so what are we looking at? We're looking from the plan view. And so let's just, like I tell everybody, everything that you see on the set is either telling you one of two things. It's describing what something is, or it's telling you to do something. So it's telling the concrete contractor what this is, or it's telling them how to do something, meaning there's a keynote here, And in this case, there are no keynotes. It's all about the description. It's all about all of the tags. Okay. And what we're looking at. So let's just go over what we're looking at. All right. SW, we will have a notification or the shear wall call out. Okay. And the shear walls help to reinforce our rough framing. Okay, so the shear walls consist of existing framing or new framing over the existing framing, along with a lot of plywood that's nailed in a lot of different, like a lot of nailing, and it helps to reinforce the building structure from shear forces like earthquake and hurricanes, and associated with that, you'll have the ties that, or the structural ties, meaning the structural metal, like you have to think in terms of like a staple, right? When we staple paper, well, think in terms of those metal ties being huge pieces of metal that you connect the concrete and the framing in various areas, so you reinforce it, right? So it's giving you the locations of the hold downs, the HDs. Okay, so let's look real quick if I can do this without messing up. Probably not. I'm going to give you the definition. Well, you know what? I'm going to do that on a different video to give you, oh, you know what? Let's see if we can find it in our master format. Let's see if we can find it in master format, the term hold down, and where we would find it. If we were looking through our specifications, this turned on me. Now the magnifying glass is on the right. Okay, whatever. So I'm going to put in the word hold down. Okay, it doesn't have it. I don't know if it's one word or two. What's it doing? It doesn't like what I'm doing. Yeah, there's nothing called a hold down. We're going to have to call it something else. Let's go. Let's look at our notes first. You know what? I don't know what's under here. My email's under there. Okay, let's do this, because when we're estimating and we don't know what something is, this is what we have to do. You know what? I'm going to put structural hold down. All right. So, yeah, something like this right here, that's a big one. But, you know how I was saying a staple? Let me see if I can. That's a big one. Simpson Strong. And ours is they're all Hiltis. Simpson, Hilti ties, whatever. Heavy tension tie. Okay, so that's how much they are each. So if you can, well, you can find them. Well, they're different sizes, right? So you have to look at your, let's see. Let me look for it. I'm trying to find, let me put in tension tie. There we go. There we go. Well, tension is in the specification. Post-tension concrete, I don't like that. That's not my favorite. But there are 17 inputs in R for the word tension in this master format. And so precast, pretension. Let's see. Let's go down and see if it talks about anything other than pre. Here we go. Tension rod and cable truss, tension fabric structures, tension, a lot of tensions. Let's see, let's go down. Marine chain tensioners, post tension concrete. Okay. So concrete is division 03. Did I already go through and it just took me back? Tension rod cable truss assemblies. Yeah, I think I did. Okay. Let's see. I want to find, let's just put the word structural in here. A lot of words, a lot of structural. Okay. 53, so let's see. Structural measures for erosion, no. See where we get into existing structural information. Here we go. Structural concrete. So somewhere in 03, it's going to give us, there we go, structural cast in place, concrete forming. And we're getting closer. Concrete reinforcing, I'm sure. Structural concrete, heavyweight, let's keep going. Heavyweight, high performance, okay. Precast concrete, structural concrete, structural clay, tile, masonry. Okay, now it took us to masonry. Okay, but concrete 03. You know what I didn't do? Reinforcement. Okay. All right. 18. Let's see if it takes us. Soil reinforcement. Rock reinforcement. Soil. Concrete reinforcement. Plain steel reinforcement bars. Galvanized reinforcement steel bars. Epoxy coated. Okay, that's bars. And let me just go through it. Okay. Somewhere in there. Somewhere in here. Yep. Let's have fun with it. Okay. So your concrete division is 03. So it will give you, or it will tell you everything about how your, and I'm just looking through here, how your, okay, remember we're looking at this in terms of being an estimator, trying to find our specification. Okay, so that's that. So let's get to the business of, what are we looking at? Okay, so let's look at some of these symbols. So remember that continuous footer I was telling you about? Well, it is represented by this broken line. Okay, so what it's going to give us, you see we have the section views. We have a number of section views. What's the purpose of the section view in the concrete is it's as if we took this and we cut open, we took it like it's a piece of bread, right? This piece of bread. We cut the piece of bread, we open it up, and now we can see the interior construction, what makes up that piece of bread. right? Because we need to know a few things. This is the continuous footer. Remember, we have the continuous footer that makes up the structural perimeter. Okay, and then if we have those footers coming in, which we do, and we're going to look at 5 over S5.60, because again, this is another piece of bread, and we're going to cut that piece of bread. And now, as the foundation concrete person, you need to know, well, what's the reinforcement? What's the thickness of the footer? What's the width of the footer? And this is going to tell us the length of the footer. Okay, and so we have section views, whether it's a floor plan, roof plan, concrete plan, whatever. Okay, reflective ceiling plan. The purpose of the section views now, because the architect can only give us so much information view to view. And in this video, in here, in this description, when we're finished, I'm going to put in the link to a video I call The Views. Because you have to understand, that's like not knowing how to go from view to view to view is like not knowing your factors and then trying to do algebra, right? There's no way in God's green earth you can do any advanced math, right, if you don't know your times tables. Well, you don't, and if you listen to my construction law podcast from today, which I'll also put in the description, construction defects originate because people don't know how to read the plans and don't know how to go from view to view to view to make sure they are following the proper procedures based on how the engineers have designed, in this case, the concrete or whatever. But in most cases, you know, how they designed the exterior wall, so they don't know to put in a layer of waterproof whatever, because they didn't go to the next view, which takes you to the next view that will tell you, okay, now one view show you to put plywood and felt, okay, but it also led you to a third view, a detail view, that said to caulk that and to flash that and to da-da-da, but you didn't go to the view, you didn't do it, or you just left it out because, for whatever reason. Excuse me. So, when you look at this, the whole purpose of these views are these section views. Now, for a concrete plan, they look different than they do for a architectural set floor plan. Okay. So, but again, if you're a framer, you're probably not the foundation person. So that's why it's good to take just a basics class, which we do provide, so you can know each set looks different, everything in it is different. And so, you know, if you're going to be in the field of construction, you should be intelligent about all of your terms and all of the sheets and everything. So, all right, so our foundation, we're going to build a new, first thing we're going to look at is what are our foundation, our continuous footers made from. And then here we have column pads. When we see something like this in this like square configuration, this indicates that this is a column that's going to be going right here. And it's a wood column, I'm assuming, because the X in construction signifies wood. Okay. And so, yeah, I'm going to go to image number 3 on page S5 dash, not dash, it's like 5.6 to show me the height. I already know the area of this column pad. It's a something by something. It's probably 4 by 4 by thickness is probably 1 or something. But a section view is always also gonna show us the configuration of the reinforcement. Okay, so we're looking at the foundation. Foundation is gonna tell us a couple of things: the continuous footers, which makes the perimeter, and possibly the interior walls, depending on, you see this right here. This broken line indicates that's the continuous footer, meaning our walls are built on blocks of concrete. And we call those, that's the continuous footer. It's continuous, a continuous straight block that is the length of whatever it tells us it is. Now, you see we have 8 over S 5.6, and here we have 2 over S 5.6, and here we have 3 over S and 4 over da da da. All that's telling you is each of those continuous footers are built differently, and so we have to go to each of those views, take a look, and do our measurements and determine. Now, one other thing is important to concentrate on and to think, well, I have something to drink. Why don't I just drink it? Hold on. I don't know if it's going to help. It will. All right. Okay. I think it's helping. All right. So, what was I saying? I don't know. Okay. So, this is what you want to think about. And remember, good people of America, if you only are seeing my beautiful face and only hearing my beautiful voice, then you need to subscribe, please, so you can see the beautiful video content and it all come together. That way it helps me to support my nonprofit, and it helps me to spend more time doing this for you. So let's go. Anyway, Patreon, there's a link in the description on how to sign up, and also a link at how to sign up at my website. Love to see you there. All right, so when you think about your foundation, you want to think about 3 things. Measuring the length of each of the different types of continuous footers. So 8 over 5.6 is one type of continuous footer that we're going to go look at, but it looks like it spans this whole length. So whatever that's going to be. And then then you have to use your intelligence, say, when it comes to the other stuff. So we see here that we don't have the broken line here. So that tells me that, and we do assume that there is no continuous footer, just a column pad and a column. There doesn't always have to be a continuous footer. It all depends on what the structural engineer decides as far as the load of the roof, right, and all of that. And it's just, it's a hotel, so it's gonna have a few floors, so this too. There's no continuous footer, just a column pad and a column. But here, there's continuous footer. And looking at the fact that they're giving us one section view, chances are they are all the same. The continuous footers are probably all of the same construction as 5 over S, okay? Unless it gives you something different, which it doesn't, so it's like, okay. Now this, clouds, right? That means that there has been a revision, and we need to go to triangle 1 to give us the explanation of that. But I could take a look here. Instead of using 1 4x4 column pad, they use 2 3x3 and 2 3x3 here. This has no continuous footer situation. This one does. Okay, so because, and two, we can infer from 3/S5.6, no continuous footer. So these look like they seem to be the same construction, 3/S5 dot here, no continuous footer. Okay, and so what I'm gonna do is measure how many linear feet of each of the different types of section views that they're giving me. And it appears that if all this side is 8/S5.6, this whole length, it appears, because it's not telling me anything different. There's no other. So it appears this continuous footer, this length is 4/S5.6, that full length. Okay, so we know in terms of the construction of the continuous footers, how they're built based on, they're giving us this. And so look at this right here is, there's something going on here. Okay, I don't know what it is. We'll know when we look at that section view. There's something going on there. And here. All right, seems to be the same. And here, revision. Because this tells me it's a bunch of, it's like maybe the mechanical room or something. And we've got some columns, but it doesn't look like we have column pads. Maybe these are columns and curves or something. So that's why we're gonna look at this. Because that's this configuration. And this section is going through this whole stretch. So it's going through whatever this is, whatever, this is. We'll be able to look at that. And that's the same as this. Okay, and so what I'll be doing, we have a section for the pit, the elevator pit, because it'll go down a little lower than the ground floor. So it's showing us basically the pit has a small concrete wall from the very bottom of the hotel floor to where the, right above where the elevator lands. Okay, and so where it has like a bunch of stuff going on. But yeah, we'll be able to look at that. That has two section views. Why? Because it wants to show us this 1/S5.6 is showing us wherever that was going through. It's going through this little type of whatever wall that is. But the 10/S5.6 is going through this darker wall. And so whatever we see here is going to apply to wherever we see that darker wall. So we're going to measure how many linear feet of that darker wall we have. And then for this one, we're going to measure how many linear feet of this wall we have. Okay, this appears to be just an opening. So maybe we have overhead portion of this wall. Okay, so that's how we break down the foundation. It has that continuous footer. We have to measure how many linear feet broken down by the section views they give us. Now, how many different column pads do we have? It's going to give us some specifications on some other sheets about the specifications of what F4 is, what F3 is, what F5 is, and we'll determine that. And then we have to fill in our area, right? We have to fill in our slab on grade, most likely all of this, but not at the pit. We've got a lot going on at the pit, right? We've got slab that goes just a little below the regular slab. And we get the information of what our whole slab is. It's a 4-inch minimum concrete slab with number 3 at 18-inch off center each way, centered in slab thickness, top to, get what that is. It's like, so what do we mean? At the 18th each way. So this length, right, divided by times 12 inches, give us total inches, divided by 18 tells us how many locations for how many locations to put the rebar that way. So it's number of locations times this length, which is what, 25 and 3 1/4 inch. So we'll have that many locations at the 18 inches times that length. Now, same thing goes, because we got to do both ways, right? Same thing goes here. So we'll have that length times 12 divided by 18. However many locations now times the whole length here. That's that rebar. So you can actually determine your total rebar total. Add 10%, and you'll be close enough. All right, so that is our first part. Let's take a little break. Let's listen to some sounds for about 2 minutes. I can get something to drink here, and when we come back, we're going to review all of the section views and understand what those mean, and then learn how to do that takeoff information for each of the section views that we're looking at. Okay, this is Stacy Johnson. This is Understanding the Plans, the Foundation, and we'll be right back. All right, this is Stacy. We back. We back. And this is understanding the plans. And do you see that big fantastic typo? I do because I'm a perfectionist. We don't know. We might have that fixed. All right. So what are we talking about? The foundation, how it's broken down, how we need to think about it in terms of its construction. I always like to break stuff down. Point one, part two, part three. Makes life easy. Everything's one, two, three. If you break stuff down into threes, it makes it pretty manageable. So remember, part one is that continuous footer that you have to look at the section views to determine the construction. And then, yeah, you got to break it down. What part is just this type of continuous footer? What part is just this type? Measure how many linear feet of each of those types. Then we go to that section view and look at the construction and then be able to compartmentalize what we see and break it down. All right, so let's just do one of these, okay? Because we will do all of these, but one is like doing them all. Okay, we'll do this stretch, and we'll also do one of the interior, and we'll do the column pads. Good thing about the cost book, we can tell the cost book the size of the column pad, and it'll give us a cost for always those three things: the formwork, form it out, the rebar, and the concrete. Okay, and so when you have a column in there, and we'll have a structural framing component of this to go over the structural framing, because this is just concrete. So our concrete, right, when we place our reinforcement, we are placing that bolt that is going into that column. We placing it there with all the other reinforcements, because we want to reinforce it in that concrete when we pour the concrete. It's not the other way around. It can't be, right? So that's why you see, if you go to a construction site, right after they drop, or right, maybe even before they drop the concrete, you'll see all the rebar sticking up. You see bolts sticking up. Yeah, because now we're going to attach our column on top of that bolt that's reinforced into that concrete. That's what makes that column a structural column. And then we do the same thing to all of the exterior walls, the hold downs and the bolts and all that. We place the walls on that, in that, attached to that. All right, so let's go to a section view. So let's go to image number 8 on page S5.6. Image number 8. Okay. So we got it. That's 9. Find 8. 6. 6. 2. How do I hate it? How do I hate this? 8. There we go. Eccentric concrete foundation at existing structure. So yeah, it's at the existing structure. Okay, so that's that bottom part. So however many linear feet, let's go back. That's it. Okay, so set the scale. Let's figure out how many linear feet of that we have. 186. So we have 186 feet of linear feet of this. Footing reinforcing shown in schematic, Dow per keynote 7, only required at optional 2, pre-existing conditions differ, contact engineer on the record. All right. So yeah. Right, remember everything on here is either telling us what something is or telling us to do something. In this case, it's telling us everything, what everything is. Okay, because we are in the structural set, it's only going to tell us what everything in the picture that is a structural component, it's only going to detail those things. Okay, and so the stud is not going to tell us, it's saying per plan, typical wood stud wall, probably 6 inch. We'll look in the architectural set for that. That's 110, most likely a shear wall. Wall sheathing occurs per plan, so that's that SW most likely. 2, anchor, bolt, typical bottom plate attachment. Okay, so we're gonna place all that prior to. 2, 12, perimeter slab rebar shall be outside AB. Now the size of the rebar, 7, style, for the footing schedule, oh, okay. Okay, so the footing schedule is gonna tell us, because this is giving us no dimensions. It's just telling us how it's built. Let's find the foundation details. Footing schedule. Okay, so that would be our wall footing. These are F3, these are our, right, our column pads, 3x3, 4x4, 5x5, with number 4, 6 inch each way. Okay, so somewhere on there, it better be telling us on that foundation plan, WF 1.5, 2, 3, and 3.5. Oh, there we go. WF 3.5. Okay, so this is WF 3.5. This is WF 2.1. Okay, easy. And the column pad. So we have again 186 feet of that. So let's go back to foundation details. 3.5, WF 3.5. So it's 3.5 feet wide by, because, okay, so I always do give my math brain experiment. And I always think, I don't know, once you do something for 14 years and it works, right? You tend to keep doing it. Okay, and so when you think about your concrete, you want to figure out, because a lot of contractors price their concrete work by how many cubic yards, okay? And all I say is figure out your cubic feet using a calculator, divide by 27. Using that same calculator, that's how many cubic yards of concrete you have. And so for wall footing 3.5, right, it's 18 inches is one dimension. The width, 3 feet 6 inches, is another dimension. And then the length of 186 feet is the third dimension. And so all of these figures you need to turn into feet. So you'll say that times that times that. So feet times feet times feet is cubic feet. and then you divide that by 27, and that's how many cubic yards. Okay, so, and as far as the reinforcement, it's easy because top reinforcement is 4, number 5 bars, continuous, CONT. So that's easy. It's 186 feet times 4, right? Because you have continuous 186. Then you have to do it 4 times at the top. And then, that's easy. And then at the bottom, for continuous with, for number 5 continuous. So basically you have 8 number 5 continuous. If you're doing in terms of your rebar totals, with a number 5 at 9 inches on center traverse. Okay, so basically, you got your, if this is the, well, let's just go to, what did it say, 9-inch traverse? Okay, so this is our footer, 3.5. And so what traverse is this way. And so you have to put that, what is it, number 5 rebar, every 9 inches traverse this way. So you have to figure how many locations by doing that math we did earlier. And then this is the length, that many locations times this length is the traverse. And then you have what, 8? Right, 4 top, 4 bottom, and then traverse. Okay, so all of them are pretty much, all the same. Okay, foundation to, now we have 3 number 5 continuous, and this was the only one, the 3.5 with wall footing. The only one that had the traverse, so. And now the column pads, okay, the thickness is, 1.5 feet, 1.5, right? Three dimensions, or, we could say, 1.5 times 3 times 3, that's feet cubed by 27. That's how many cubic yards of concrete per column pad. And then you know how many column pads you have, 4, 5, 6. Do that math. Okay, so, and then of course for your slab on grade, right, it's just your area. You're just going to include everything. Your slab on grade. Now, let's look at this, our pit, because the pits are usually a whole different beast. All right, so we're on a slab on grade. We're going to do that right there. That's easy. All right, so let's take one more break, and we're going to come back and break down that pit, because that pit is not easy. This is understanding the plans, the foundation, and this is the construction queen. Hold tight. We'll be right back. All right, let's go. This is the construction queen, the queen of construction. And you know, I got to thank you guys. And there's going to be a shout out on Sunday between 12 and 5 on my nonprofit website, SF Johnson Family and Community Services. Hope you join us there. It's all family oriented. We'll have some music. We'll have some, one of my favorite movies, Teen Titans Goes to the Movies. Oh, it's great. It's music, stuff for kids, nature, fun, music, just the 5 hours of fun. And so we hope you join us. We hope you subscribe so you'll be our good friend over this crazy time in this world. It's not just about teaching you how to be an awesome construction person, it's about being your friend. All right, so let's finish this up with looking at our pit, because most of the time when I have to do a foundation, we have to do the pit. We have to, it's usually like the pit for this is more like you got to think in terms of a wall construction instead of just you know, you know, a width or height of 18 inches or something like that. So let's go ahead and look at the outer portion of the pit, the concrete portion, and that would be, well, we're going to look at actually 10 and 1 over S5 0.6. Let's look at 1 first. If I can find it. All right, so 1. You would think it's like 1, 2, 3, 4, 5. It's not. So here's 1. Okay, yeah, here we go. Concrete wall at elevator pit. You see? So for our 4 is the elevator pit slab. So we have to go back to that plan view and square that out. Okay. Have to go back and see how many square feet of that we have. It's a foot thick, and there's somewhere. Oh, okay, yeah. It tells us it's number 5. Every foot each way, top and bottom. That's 4. Okay, and then yeah, we have to think about our wall, which is only this length from here to here. So basically our wall, and this is our thickened edge, that's not included. That's included in our, basically in our wall footing, our continuous footer. Okay, so we have 5 feet minus 8 inches would be the height of our pit. Okay, and so that's 1. That's just 1, right? We have 1 and 10. So let's see what 10 is looking like. Where's 10? Like it's so small and I can't see it. And hold up, let's find it. Where's 10? Oh, jeez. Okay, there's 8, 9, 10. Okay. And this is a totally different beast though, right? This is a 4-foot wall, straight out. Point to it, 8-inch thick. The number 4s, provide stud hook on vertical. Bars use dowels at every foot, off center or bend. Okay, that's 5. Oh, that's 5 here. That's the dowels. So that's the connection, the reinforcement between the wall and the foundation, and then the wall itself. So the same way we determine the, how much, whatever. So let's go back to, so our slab pit is, okay, this area. We just do it the whole area. It's not gonna hurt us. Okay. And then I would give the 10 portion where it was gray, and then the 1 portion where it was all white. And you've done your foundation, okay? And you've become extremely awesome doing it. So if you have any questions, please put it in the comment section. Please make sure to subscribe here, Patreon, and at SF Johnson Consulting. And thanks a lot. Please give me your comments. Let me know what you think. And I'll see you next time.